Whether my voice is audible. Krishnaveni, whether my voice is audible, ma? I see. I think two students have only joined. I will wait for some 5 more minutes and I will start. And I have to complete 4 weeks of assignment, or else they may go through this YouTube live link. Okay, Ashish Kumar and Krishnaveni, any of your friends have been joined in this NPTL, joined in the exam? Ask them to join immediately, because we don't have any time to teach in the college. So ask them to join immediately. Students, those who have joined, kindly put the message. As of now, only two students have joined. Okay, I think uh, the time is around 5:57. So it's going on live. Okay, I will start from week zero. You have any doubt? You just put it in the chat box, or else you come and ask me directly. Okay. So today I try to cover the 4 week. Okay, but I start with. Okay, let's start with week zero. Students, whatever the points I ask you to make note down, kindly note down, because it's a 12-week assignment. Studying this entire assignment will be somewhat difficult for you. So you make note of this and prepare well for the exam. Okay, now smaller unit of binary data. We all know what is the smaller unit of binary data, na? That is bit. Bit is smaller unit of binary data. What is nibble, na? Nibble 4 bits. Byte, na? 8 bit. Word, na? 16 bits. So once again I'm repeating, nibble 4 bit. Okay, bit is we used to say 1 bit or 0 bit. Bit is a single bit. Okay, byte 8 bits. And word, na, we have to say that 16 bits. So smaller unit, na, this is 4 bit, this is single bit, this is 8 bit, and this is 16 bit. So byte is the smallest unit. 64 bit word consists of 64 bit consisting of how many, na? You all remember 8 bytes. 8 bytes, now why it is 8 bytes, na? 1 byte equal to 8 bit, so 8 into 8, 64 bit. Okay. What is the high speed memory between the main memory and the CPU is the cache memory. Normally, the cache memory is the high speed memory. Okay. How many possible ways of digital signals? Digital signals, we have only two possible way. One is 0 and another one is 1. What is the number system has a base of 16? Okay, that is hexadecimal. Hexadecimal is base 16, decimal base 10, octal 8, binary is base 2. So hexadecimal is base 16. Single flip flop can store how many bits? Na? A flip flop can store only 1 bit at a time. Okay, flip flop is a binary storage device. It can store only one bit at a time. So answer is 1. CD-ROM. What is CD-ROM now? Compact disk read-only memory. Which of the following statement is not correct? Okay, actually, when you see that music on a CD is a digital signal, yeah, we used to write, and LDR is an analog signal. Depending on the variation of the light intensity, my resistance also varies. Human voice is a digital signal. We all know the human voice is always in a varying nature, so it's not a digital signal. Room temperature is an analog signal. So all other statements are true. Only one is this one is false. Which type of following best describes the random RAM? Okay, RAM, random access memory. They lost memory when power is removed. That's correct. And a type of memory in which access their time is same for any memory location. So that will be that, but it's here the A point is in which access the time depends on memory location. It's same for any memory location. Okay. CPU stands for Central Processing Unit. Okay, so I think the first week zero assignment, it will be very simple only, so you may understand well. Okay, shall I move on to the week one, ma? Okay. Actually, whatever I'm telling, you make note of it and then prepare for that. Actually, week one is somewhat about digital only. Okay. So listen, this is about completely digital only, so you may understand well. Which of the following 5-bit two's complement of -10? So we all know that -10 na, it's a negative number. Negative number, they are saying 5-bit. 5-bit na, 10 is represented using 8421 code. 8421 code na, you may see that 1010. This that you all understand the MSB bit will be considered as a sign bit. So if it is 0 na, it is a positive number. If the particular sign bit value is 1 na, negative number. So minus 10 na, you have to understand that I have to take what complement now? 2-bit, 2's complement. 2's complement now, what is 2's complement? You have to convert that given number into uh, 0 1 0 1, and then you have to add 1 with that. 2's complement na, transfer the content. Okay, transfer, change 1 to 0 and 0 to 1, and then add 1 with that. -10 now, what is the meaning of -10 now? For sign bit I have to put it as a 1. Okay, that is the thing. What is the following octal number equivalent of 55516? Okay, I think okay, 55516 na, you have to write this 555. Okay, this is the reverse process. Which of the following is octal number equivalent na? The answer is given as a 1053. So you represent all this number in a what form na? Octal form. Octal form now, 1 means how will be we are writing now. You make it as a 3 digit, then you group into 4 digit. So you will get it. So it is nothing but octal to hexadecimal conversion. So even though you are the second year, you have been know how to convert octal to hexadecimal. Once again, I am repeating, write this octal number in 3 digit. Okay, using the code of 421. Then you group 4 binary digit. Then you will get this value. So you have to do it for A, B, C, D. Which will be more been precious, na? Which is more correct, na? The A option is correct. Okay, then binary equivalent, fractional number. So first you all know that this 88. So 88 divided by 2, we have to keep on division. and 67, 0.67. So you have to multiply with 2 power minus 1, 2 power minus 2, and then you get the value. So the correct answer is nothing but a decimal to binary conversion. So decimal to binary conversion, now we have to do that 88 for continuous division method and 0.67 for continuous multiplication. Okay, and which of the following is decimal equivalent of 524.395? You all understand converting the decimal equivalent. So here they have given what is the base value 5. So how I have to do now? We all know 4 into 5 power 0 plus 4 into 5 power 0 plus 2 into 5 power 1 plus 5 into 5 square. Then when you go for the fractional part, 0.3 into 5 power minus 1 plus 9 into 5 power minus 2. If I convert, I will get it the equivalent hexadecimal value. Okay. So then this is the number. Okay, 6-bit in 2's complement form. Identify the range of numbers represented. This is the form that we used to say it's a signed number. Minus 2 power n minus 1 to 2 power n minus 1 minus 1. So 2 power n minus 1, 2 power 15 you have to calculate. Minus 2 power 15 to 2 power 15. The formula is given. Use that even though 8-bit is given or 4-bit given, you have to use this formula to calculate. Which of the following is not a digital logical function? We all know the combinational logic is nothing but adder, multiplexer, demultiplexer, decoder, encoder, all are the combinational logic circuit. Sequential na flip-flop, asynchronous counter, synchronous counter are the sequential logic. So only not a logical function, na, it is a parallel logical function. Okay, what is the sum of 10110 plus 0110? We all know that 0 plus 1, 1. 1 plus 0, 1. Then 1 plus 1, 0 and carry will be 1. Again 1 plus 1, 0, the carry will be 1. Again 1 plus 1, 0 and I will get the carry will be 1. So here I am doing 5-bit addition, but I all know I am getting the carry of the 6th bit. So my answer will be is that it's a normal binary addition. Okay, here you see they didn't give the value of base value. Okay, just they give 49. So how we have to calculate this now? Students, I think the first unit is completely that week. One is about completely about the digital logic circuits only. Okay, so you see to that. 49 power 16 equal to 41x now. You all know that I don't know the x value. So how they are doing now? 9 into 6 power 0 plus 4 into 6 and here 4 into x power 0 plus 1 into x. So I will get this expression. By solving this expression, I will get my x value of 8. Okay, that is which of the following is the truth table of 2-input NAND gate? NAND gate now it is a inverse of AND gate. We all know AND gate. This particular truth table is correct one. 1 is actually 1. The remaining all 0 for AND. So NAND na inverse of that. So by seeing the truth table itself, we can conclude. Which of the following is truth? Okay, half adder circuit. I think combinational circuit we have studied this half adder circuit. So half adder circuit I want to perform now. Sum is nothing but XOR of XOR with Y and carry is nothing but AND. So here you see that A XOR B I used to get the sum and carry is nothing but A and B. So no XNOR operation. Okay, and here also no OR circuit. And here this symbol is for AND. So this is AND symbol. So that is also wrong. So I think the first one is correct. A with A XOR with B, I will get the sum value. A with AND B, I will get the carry operation. Which of the following component present in computer? I think CPU, memory, peripherals. Okay, all A and B is the answer. How many half adder are required to build a full adder? So we all know half adder I have to add 2 bit. Full adder I have to do 3-bit addition. So definitely half adder, I require one more half adder to perform a full adder. So 2 is the correct answer. Okay, 2 half adder is required. Which of the following statement is false? I think now we are going to enter into the 8085. So students, while we are moving on to the 8085, I will give you small introduction about 8085. Okay, now you may see to that uh, here 13, 14, and 15. Okay, so I will tell you 13, 14, 15, and then I will explain the general concept of 8085 and I will move on. Okay, just you see which of the following is a program counter points out the next memory in the location. So you all understand that microprocessor program counter will always hold the next instruction in the memory. That is the purpose of program counter. Instruction decoder will decode each and every instruction. That is also correct. ALU means arithmetic logical unit, performs arithmetic and logical operation. Flag register stores the result of any arithmetic operation. So flag means here we have a carry flag, parity flag, zero flag, and all. That is, we have a separate flag register. So our any arithmetic operation result will be stored only in the accumulator. So the D statement is only false. Okay, flag register stores the result of any arithmetic operation. In that, this is the false statement. Okay, the remaining all three are true statement. You make note of this 13th question because all other are true, only the fourth statement. Okay, now you come to the picture. Here it's a problem, a simple problem. You all understand what is 8085 now. Note down that 8085 having a 8-bit microprocessor and a 16-bit address bus. So here 4 KB RAM. I think nowadays we don't have a RAM in 4 KB. All are in GB and all. But previously 4 KB RAM now. That it's depending on the address bus length only. So what is 2 power 10 value? 2 power 10. I think I will put what is 2 power 10? Can anyone put it in chat? 2 power 10 is what, ma? 2 power 10. Students? Yeah. Yes, Yash is correct. 2 power 10 is 1 KB. 2 power 11, 2 KB. Am I correct? 2 power, yeah, Divedarshini also correct. 2 power 10, 1 KB. 2 power 11, 2 power 11 is nothing but what? How much KB, ma? 2 KB. 2 power 13, yeah, 2 KB. Yogeshwaran, correct. Okay. Okay. 2 power 10, 1 KB. 2 power 11, 2 KB. 2 power 12, how many KB? 4 KB. So I want to have an address bus now. 4 KB RAM now. I need how many address bus? 12 address bus. How they will decide the address bus now? Always remember 2 power capacity. So 2 power 12. It's very simple problem. Understand well. 2 power 12 equal to 4 KB RAM. Are you clear? 2 power 12 equal to 4 KB RAM. In this 8085, we have 16 address lines. So how they will mark the address line now from A0 to A15? A0 to A15 now we all have how many address lines? 16 address lines. So 4 KB RAM now you understand that I need only 4 KB RAM now I need only how many address lines? 12 power address lines. 2 power 12 equal to 4 KB. So here I am having the 4 lines to select for chip select. So you they put A, this is nothing but A13 they put now A13 bar. So what is the value now? 1101. Are you clear? 1101. So 1101 now you have to understand that 1101 value is what? D. Okay. So here I'm having 12 4 KB RAM. 4 KB RAM now 12 address lines. How they are right now? I think I will stop share it and I will share the paint. Okay. I will share my paint. Then only you can understand how they were writing. Yeah, can you able to see? So now I'm going to explain. We all know 2 power 12. We have how many ma? 4 KB RAM. Okay. Here 8085 we always represent in hexadecimal. Okay. Hexadecimal now you remember A0 to A11. So A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11. So the memory na 0, 0, 0, 0, 0. You all understand? I have to group in hexadecimal. Okay, this is minimum value. What is maximum value? 111, 111, 111. Okay, so group 4 values. So this value is nothing but what ma? 0, 0, 0. 111 now according to the hexadecimal, we all know what is the value. F, F, F. So while moving from FFF, you may see to that here A15, A14, A13 bar, A12. So A15, A15, A14, A13 bar, A12 bar. Okay, so value is 1101. 1101 now we all know what is the value? D. D, D, F, F. I think I didn't share the screen. Okay, okay. Sorry. Now is it visible? Okay, okay. I think it's not visible. Okay. I think now it is visible for you. So 2 power 12 to so 2 power 12 now 4 KB RAM. Okay, 2 power 12 now 4 KB RAM. In the 4 KB RAM, how I am writing now A0 to A11. Okay, that is 12. Now I think you can visible. Am I correct? Now can you able to visible? Okay, A0 to A11. So totally how many bit ma? 12 bits are there. So in the 12 bit, I have marked that value. Okay, and then I have marked A15, A14, A13 bar, A12. So that value is what? 1101. So my starting value is D000 and my ending value is DFFF. Okay, so this is the way. Normally, we use 16 bit. Okay, you make note of this, how we have written the value. So, the 4 KB, how they are deciding the 4 KB now? 2 power 12. 2 power 12. Okay, if it is 8 KB now, 2 power 13. Okay, if it is 16 KB now, 2 power 14. If it is uh, 32 KB na 2 power 15. If it is 2 power 16 na 64 KB. So the maximum is 64 KB. Okay. Now I think I will stop share it and I will share the Chrome tab for you. So you think you have make note of this, how we have solved. Okay. I think students. So 2 power 12 4 KB RAM, the remaining 4 bits. I told maximum in 8085, how many address bus we are using now? 16 address bus. So 12 address bus, I have shown in that paint, same thing only. So now we go on to the next problem. See, in the next problem, Ah, you see, 4 KB RAM. 4 KB RAM means we all know that 2 power 12. Okay, 2 power 12 now, we all know that the last three digits are 00 to FFF. All the options are having same value only. But here we have to look up for A15 bar, A14, A13. Actually, they allocated 4 bits for chip selection. Here they allocated only 3 bits for chip selection. So how we have to take now? A12 bit, they didn't assumed anything. So what we have to do now? A15 bar 011. Okay, we have to have a two option 0110, 0111. Okay, A15 bar, A13, A12 now. We have to make it of two choices 011 and 0111. So 0110 now we all know what is that value 6. Okay, 0111 now what is the option we have a 7. So the option is D, that is nothing but 6000 to 6FF, 7000 to 7FFF. Yes, have you understand? Now PDF is visible. I think the 14th and 15th problem, I thought kindly put it in black screen, ma'am. Only you put not visible, Amma. Yogeshwaran. Oh, then I'll show. Sorry. There is a problem on sharing in YouTube. That's why I have been. Now it is visible. Ah, okay. Thank you. Streaming problem. Okay. Sorry. So this problem, see the 15th problem, 4 KB RAM. Once again, I'm repeating 4 KB RAM. So 2 power 12. Okay, 4 KB. So remaining 4 bits are there. Always remember, please make it as a hint. 8085 na data bus length is 8 bit. Okay, address bus length is 16 bit. So we need how many address bus length na 16. But they given only for 3 bits. And here 12 bit. So 12th bit, we have to take two choices. What are the two choices now? A15 bar. A15 bar na 011. A12. I have to make it two choices. One is A12 equal to 0 and another one is A12 equal to 1. So here 0110. Another one is what? 0111. Okay, 0110 now we all know it is 6. 011 now what is the value? 7. So 6000 to 6FF, 7000 to 7FF. Yeah, 00 to FF will not change for 4 KB RAM. That is correct. But this for three address lines given for chip select, they didn't mention about A12. So we are keeping two choices. Previous question 14, they given the choice. Here they given A12 value. So 1101. That's why what we did D0 to DFFF. But here they didn't mention about the A12. So we are making two choices. If A12 is 0 or if A12 is 1. So I think the first week of the assignment get end. Okay. Can you able to understand? The first week assignment get end. Now I will move on to the second week. First week, okay, shall I move on? Okay. Second week assignment. Before I am moving on to the second week assignment, please in the lecture material, I will give you some notes. You need not to study the entire lecture material. So take one pen and paper and you just note down whatever the important slides I'm telling. You just take a note down or snapshot. And this is not only for second week. I'm going to tell for second week, third week, fourth week. Are you all clear? So you just note down. Okay. See, you need not to study the entire lecture material. Okay, microprocessor na it's a CPU. We can access input, output, and memory. Okay, memory we have RAM, ROM, registers, and all. Okay, so totally you see 64 KB is there. 64 KB na 0002 FFF. Please keep the memory range. Please write down the memory range 0002 FFF. This lower range and this upper range. Kindly note down. How many address bus length is there? 16. So what is 2 power 16? 64 KB. If I convert this FFF, we all know it's a hexadecimal number. If I convert, the equivalent decimal value is 65,536. That is only we are rounding off to 64 KB. So this is my address range 002 FFF. Okay. I think I will show my PPT. That will be quite easy for you to understand. Okay. Students, because I have been written in a easy way. Okay, you. So here three buses are there. You note down address bus, data bus, and control bus. Address bus, data bus, and control bus. Okay, this all called as a, what is bus na? Group of bits. Group of bits is address. Bus. Group of bits is nothing but address bus. So address bus, data bus, and control bus. Just note down this. Whatever I am telling, just note down that alone. You need not to note down all. Then kindly take the screenshot of this particular PPT, particular slide. Please kindly take the screenshot of this particular slide. Okay, so here we are having this group of signals are there. Okay, so when we will see about the signals, we will see to that, or else I will start from this. Okay, always microprocessor need plus 5 volt and ground. Processor need supply voltage and ground. What is the supply voltage? Na? Plus 5 volt and ground. Okay. And SID, SOD, na? It's all serial IO port. Even though you imagine this processor are in 1970s, so still they think about the serial communication and they have been developed. SID, na? Serial input data, serial output data. Okay. Interrupts. Note down this 5 interrupts. Trap, RST 7.5, RST 6.5, RST 5.5, INTR. This or RST restart. Okay, this are hardware interrupts. We can generate this interrupt only in hardware. What is interrupt? For example, my processor is executing one thing. Okay, suddenly the interrupts will interrupt. For example, it may be an emergency condition, or it may be give attention to the any other processor and all. So at that time, my processor will see and execute that instruction, whether I have to execute that interrupt instruction or not. That we are classifying this 5 or comes under the hardware interrupt. Interrupt means always comes from the yeah, software as well as hardware. So once INTR, first interrupt will not directly come into the processor, it always asks request. So processor have always two signal. Request na, the external will ask the processor for request. Once it is saying okay, do it further na, it is a acknowledgement signal. So INTR is request and INTA bar is interrupt acknowledgement. Here R always stands for request and A always stands for acknowledgement. So trap RST 7.5, RST 6.5, RST 5.5. Okay, INTR. INTR only first processor will receive. Among this, which is highest priority? Na trap. Why it is highest priority? Now in used in the where it will be used now, normally it will be used in the emergency condition. For example, in one particular processor is working under the mall, there is a emergency condition. Definitely processor have to put the attention, whether may be a fire accident or any other theft and all. Once it receives the trap instruction, it shut down all other processor and it will pay to the attention to the trap. That is the trap instruction. So a trap is the highest priority interrupt. Okay. RST 7.5, 6.5, 5.5 or other interrupts. Okay. INTR is interrupt request. INTA bar is nothing but interrupt acknowledgement. INTA bar is interrupt acknowledgement. Okay. Make use of it. And this or read bar, write bar or nothing but these are the clock signals. ALE na address latch enable. Okay, I will explain you what is the purpose of ALE. Hold HLDA, another important signal. What is hold? What is HLDA? Na? Processor wants to share the address bus to DMA. DMA means direct memory access controller. Na? Hold is relinquish the system bus. System bus, now we have seen address bus, data bus, control bus. That will be taken control by the DMA. So hold will be the signal received and HLDA will be the acknowledgement. Okay. Then what is the clock frequency of the processor? Na? 3 megahertz. You just imagine nowadays the frequency in gigahertz, processor frequency. 3 megahertz na time period is less. Gigahertz na time period is will be, we all know that the speed will be very high. So previously very first 8085 will operates in the megahertz range. So this PPT is very important slide. So make note of it. Then I will go for that. Okay, I have shared this PPT in our drive link. Okay, this is our architecture of 8085. Okay, you see interrupt signal, serial control signal, timer, address bus. Address bus now here you have seen AD7 to AD0 to AD7. What is here now? Multiplexing will be there. What is multiplexing? Multiple input, single output. So AD0 to AD7 will be multiplexed. And what is the remaining signals? A8 to A15. Can I actually I will stop share it and I will go with the paint. So now you see how they have been seeing now. It's one of the important concepts. That's why I'm telling. 8-bit D0 to D7. It's my data bus. Okay. How many bit long? 8-bit length. A0 to A15 is my address bus. How much bit length na? 16 bit. So here what they will do, multiplex na AD0 to AD7. Okay, plus what is the remaining address bus signal? A8 to A15. So here multiplex na in same wire it will carry address and data. So to separate this we always need one signal, that is ALE, that is another important signal, address latch enable. Okay, so why we are been doing like this na? If I use directly, how many bus I recur? 24 bus. You imagine I am recure 24 bucks. But here one 8 bus, 8 bit, and here one 8 bit. So totally how many bit I recure na? 16 bit. Here I recure how many bit? 24 bit. So always they will multiplex the address bus and data bus. So using multiplex, the number of uh, bits used in the register get reduced. So always we will multiplex. So normally how we will multiplex now? I will stop share it. Okay, my screen is black. The problem is while whenever I'm sharing, okay, I will share it now. Now it is visible. So D0 to D7 data bus, A0 to A15 address bus. Okay, and both are multiplexed, AD0 to AD7 and A8 to A15. So this is the normal thing. So you kindly take down this also. Once again, I want to tell A0 to A15 is address bus. Okay. D0 to D7 is data bus. Okay. Data bus. 2 power 16 is 64 KB. Now both are get multiplexed na A0 to AD7. 8 bit is there. Then A8 to A15 is there. I want to separate this address and data na. I need what signal na? ALE signal. I need ALE signal. Okay, please kindly note down this. Okay. Okay. Now I will directly move on to the. So I think you have seen this. Okay. This is the architecture of 8085. This is the architecture of 8085. Okay. So go through this. Only five. Take down the print snapshot of this flag register. Take down the snapshot of flag register. 5 flags are there: sign flag, zero flag, auxiliary carry flag, parity flag, carry flag. Kindly note down. So carry na, whenever it exceeds 8 bit, carry flag will set. Parity na, odd number of ones, there are no odd parity. Even number of one na, even parity. What is auxiliary carry na? You all remember it is, we never use the auxiliary carry for the programming. If the carry bit is from generated from the third bit to fourth na, auxiliary carry will set. So auxiliary carry will set whenever overflow is occur in the D3 bit. D3 bit. Okay, zero flag. Whenever all the values are zero in the accumulator, zero flag will set. Sign na, we have seen in that. If the sign bit is 1 na, negative number. Sign bit is 0 na, positive number. Are you clear? Sign bit is 1 na negative number, sign bit is 0 na positive number. That's it. Okay. So here we are seeing hexadecimal number system only. Okay. Instruction. Okay. We all been seeing here we have 5 types of instructions are there. Okay, you need not to study all the instruction, but we know how to classify 1 byte, 2 byte, 3 byte. It is they are asking in repeated questions. Okay, how to identify 1 byte and 2 byte? Now very simple. Please take the snapshot of this. Okay, opcode alone is there 1 byte. Opcode plus 8-bit data or address is there 2 byte. Opcode plus lower order byte with higher order byte address is there, that is 16-bit. Please kindly take the snapshot of this. Okay. Okay. So now I will tell you why 8-bit data na we all know 8085 is 8-bit data. Lower order byte, higher order byte, why they are saying na? You all understand that here my memory capacity is 64 KB na. In each memory it will have only 8 bit of data only. So 8 bit na 1 byte. So first memory it will occupy 1 byte, second memory it will occupy 1 byte. Okay, now we will see for 1 byte instruction. You see, these are the example. Move C comma A. Here no 8-bit data. Just see that here we don't have any numbers are there. So that means it is comes under what instruction? Single byte instruction. Okay, move, add, CMA na complement. Okay, now we go for 2 byte instruction. MVA comma data. Data na it is 8-bit data. See 1, 2, 3, 4, 5, 5, 6, 7, 8. 8-bit data. Sometimes they will give it in hexadecimal. That is also 8-bit data. So one for MVA and another for data. So we have a 2-byte instruction. 3 byte na see jump. This is address. JMP na jump. So we have 20, 1 byte. 85 is another byte. So for jump 1 byte, 20 1 byte, 85 another. This is nothing but our address. We all know our address range is from 000 to FFFF. So it requires 3 byte. Okay. Then 5 types of addressing modes are there. Okay, register, direct, register, indirect. Among this, very important addressing mode is this. Take down the screenshot of this. Take down the screenshot of this. I'm telling whatever you want to take the screenshots, that alone necessary for you to prepare this. Okay, STN store the accumulator content. That is direct address. Directly I will have the address. Move A comma B na I have to move my B register to A. Move A comma M na M is always indicates the memory of HL register. Okay, MV na move immediately. Move immediately accumulator with 18. What is A? What is B na? We have so many registers are there. I think I will show you this architecture. Please kindly go through this architecture. You see, I'm having, yeah, color one. Okay, this is fine. Okay, here you can see this W and Z are temporary registers. We cannot access. So note down, take this alone, you screenshot. B is one register, C is, it doesn't have any name. B, C, D, E, H, L. I can use it 8-bit. If I combinely BC na, I can use it 16-bit. D 8-bit, E 8-bit. I combinely use 16-bit. H 8-bit, L 8-bit. Combinely I can use 16-bit. Apart from that, we have a program counter. Program counter will always hold the next address of the instruction. Okay, stack pointer. Stack pointer is a memory pointer indicate. So BC, DE, H. But this program counter and stack pointer I can use only as a 16-bit. Okay. Then you take it accumulator. What is accumulator? Now accumulator is a primary register. Accumulator length and 8085 length will be same. So this is 8-bit now. My 8085 also 8-bit. Flag, why they put 5 now? 5 flags are there. We are seeing now. Sign flag, zero flag, parity flag, auxiliary carry flag, carry flag. So that's why they put flag 5. Okay, so I think we will move on to the assignment. Okay, if I ask anything you want to take the snap, you take that alone, you snap. Okay, see here, this is the signal, how it is transporting. Okay. You see, higher order address bus A8 to A15, lower order address bus AD0 to AD7. So if my ALE goes high, ALE na I told address latch enable. So goes high na, it will separate the lower order data bus and address bus separately. Okay. So these are the T states. What is T states na? 3 megahertz microprocessor. 3 megahertz na 1 by 3 megahertz. So I think 1 by 3 megahertz na 1 by 3 na 0.33 microsecond. Okay. This is the thing. The remaining and all not required for you. Okay. And I will show you. These are the 5 types of instruction: data transfer, arithmetic, logical, branching, and control. But no need of studying all the instruction sets. Okay. Now I will go for the lecture material with the assignment. Assignment 1 we have completed. Now I will go to assignment 2. Okay. Please kindly note down of assignment 2. Okay, students, we will directly move on to the assignment 2. Okay. Which of the following statement is true? Microprocessor includes ALU, registers, and control units. Microprocessor includes ALU, register, IO unit, and control unit. 80 microprocessor has 20 pins. 8085 microprocessor higher order pins are multiplexed with data pins. So, which is correct statement? Actually, microprocessor includes ALU, register, and control unit. Why it doesn't have IO unit? Now, IO na input output unit, it will be connected in peripheral. So, B statement is false. IO unit will not be present in the microprocessor, it is a peripheral. And microprocessor, I have shown one pin diagram now. 8085 microprocessor has 40 pins, not 20 pins. So that is wrong. Okay. And here 8085 higher order address pins are multiplexed. No. We have seen that lower order address bus are multiplexed with data pins. So the correct statement is A only. Okay. Then in this instruction, we have only 3 operation: fetch, decode, execute. Please kindly note down, we have only 3 operation: fetch, decode. What is fetch na? It will go to the instruction and fetch the instruction. Decode na, it will convert that hexadecimal value into binary, and then now my machine can understand, it will execute. So no encoding and decoding logic will not be in the machine cycle of 8085. Remember, fetch, decode, execute. That is the 3. So the last one is encode is wrong. Okay. One more state is there: fetch, decode, execute, storage. That is also possible, but encode is not available. Okay. Some of the books they refer fetch, decode, execute, and storage. But here encoding is not there. Which of the following statement is true? Machine level languages are different between different between manufacturer. Machine level are same between the manufacturer. Assembly languages are same between manufacturer. A program written for 8085 can be executed on 6800, vice versa. Listen, 8085, I'm keep on telling now, that is 8-bit microprocessor, which is developed in early 1970. Still in IIT, they are keeping that particular processor as a in the syllabus now. We have to understand it's a very base one. It is Intel manufacturer. 8085 you are learning in this. That is Intel manufacturer. Next to 4 units, 4 weeks about 8051. That is Intel manufactured microcontroller. That we will see what is the difference between processor and controller. But processor, na, we all know it have a register, it have a IO unit, it have a control units. But The Intel is very popular. Why? Because now the structure they are easy, that everyone can understand. At that time, Motorola, Zilog, so many manufacturers have developed so many processor, but all that processor will be in the failure stage comparing with this. So you have to understand every machine language are different between the manufacturer. It's not same. Okay, what is they have written 6800 na? I think it's a Zilog processor. So what is assembly language na? I told now fetching the instruction always will be in hexadecimal. Okay, that we used to say assembly level language program. The difference will be assembly level language now we use hexadecimal system. Okay, machine level language zeros and one. So machine level is also different. Assembly level language, because here they use hexadecimal system, and now in Arduino and all we are using embedded C coding. So there it will convert into a separate one. So machine level language are different between the manufacturer. The A1 is correct statement. Which of the following statement is false? I think I am showing the answer. 80585 require 5-volt power supply. It's a true. Okay. 10-volt power supply. No. None of the processor. That is false. 8085 is a 8-bit general purpose microprocessor. That is also true. 8085 can operate with 3 megahertz clock. That is also true. So if I want to tell about 8085, see, I can read the ACD point. 8085 requires 5-volt power supply. It's a 8-bit general microprocessor and it is operated with 3 megahertz clock. Okay. Now, which of the following pins connected to the frequency generator? I think I ask you to take one snap on that now. In that we will mention the pin detail. So normally pin 1 and pin 2 we will externally connected. I think I will show in the diagram. I will show you. After this I will show you pin 1 and 2 of an 8085 microprocessor. Okay, what is the address bus size? Now only we have seen 16-bit. What is the status of sign bit when an arithmetic returns a positive number? So I told the sign bit value is 0 na positive number. Sign flag is 1 na negative number. This is that. What is Z state na? That is impedance state. Okay. Z state we used to say. So it's a high impedance state. Okay. We have 3 state in processor. We say 1, 0 and Z state. But flag we have only 2 probability. 1 and 0 only. Okay. What is the following statement is true? We have seen that now. Auxiliary carry now, if there is any carry is generated in the third bit, the auxiliary carry flag will set. So only the statement is, the A statement is true. Auxiliary carry is set if there is a carry out of bit 3. Okay. LIFO 8085 is working on the principle of LIFO. Last in, first out. Okay, LIFO principle, last in, first out principle only. It's how many clock signal has whole say its address bits? Normally, maximum when you take four clock signal only, we'll all mention for the holding the address bus. But among that, while I'm showing, it is holding only 3 signals only. 3 I ask you to take one snapshot ALE and all. That time it will hold only 3 clock signals. Okay, how long it will, the fourth will be unspecified. Okay, the higher order will be remains on the bus for 3 clock periods. Okay, I think if I went outside, it is not showing. Okay, I will show you which of the following operations are performed by ADM. ADM na memory. So I told the memory is indicated by which register? HL register pair. Okay. ADM na HL with accumulator. Always remember addition and or any arithmetic or logical operation I want to do, I can do only with accumulator, A register only. Add M na A plus M. M is specified by HL register. Add B na A plus B. Add Z na A plus C. Add H na A plus H. So accumulator with any other only the value. Okay. What is CMA? CMA na complement the accumulator content. What is my accumulator content value? 0, 1. 0, 1 na you understand? 0, 0, 0. Apra 0, 0, 0, 1. So you complement na 0, 1 will become what? FE. I think you write this 0, 1 in hexadecimal. Mention 0 for 4 zeros. And 1 for how many ones? 4 ones. So you see, 0 1 na, how I have to write it in hexadecimal na, you remember? 0 0 0 0 0 1. This is in binary and this is in hexadecimal, the subscript. Complement na, 0 will become 1, 1 will become 0. So 1 1 1 1 1 1 0. So this all 4 1 I can make mention as a F, and 1 0 I have to mention as a FE. So what is my answer in the accumulator? FEH. Yes, that is the meaning of that. Okay. Now you see, in Intel 8085 microprocessor, ALE signal is made high to enable the data bus to use as a lower order address bus, because we are multiplexing the lower order address bus and data bus only. So for that only we are using ALE. So understand that, not higher order. Which of the following are the content of 8085 microprocessor flag register? Flag register, na, I told. Flags are there: sign flag, zero flag, carry flag, parity flag, and auxiliary carry flag. Which of the following operation performed by DCX BC instruction? What is DCX na? Decrement the register pair. DCX na, decrement the register pair. What is pair? What is na? I will tell you. I will share you. Okay. Okay. Now I will tell you what is that question. One second, wait. DCX BC. Okay. Now see, what is BC now? You understand? I can use this B as a 8-bit and C as a 8-bit. Okay, remember. If I am using both na, BC as a 16-bit. Okay. If I am putting DCR B na, it will decrement only B register. DCR similarly, INR B na, it will increment only B register. Okay, so B value will be decremented by 1, and B value will be decremented by 1, and E value will be incremented by 1. But DCX na, decrement the register pair. X stands for register pair. DCX B na, BC value will be decremented by 1. I similarly, okay, INX increment the register pair. So that is BC plus 1. So please note down this. This is using register. Okay, this is using register. And this is using register pair. Register pair. So DCR for register, X for register pair. Okay, please kindly note, take down the snapshot of this thing, then you will understand. Okay, now Okay, so you can understand what is DCX nama? Decrement the content of B by 1. That is wrong. DCR. DCR B. This is DCR C. This is DCX BC. Okay. And content of C is decremented, but content of B is unchanged. Okay. Actually, decrement the content of register pair X knowledge register pair by 1. Okay. And now I told you that I will share you the one thing pin detail of that. Okay, I'll go to this. I will share you. Okay. Mm. Now I have asked one. Na? Okay, please. See, my 8085 is having 40 pins. This is only I have shown you. 40 pins. There are 40 pins are there. So this X1, X2 always stands for what? External clock pulse. Okay. This 20th pin is ground pin and this 40th pin is clock pin. Okay. Sorry, supply pin, plus 5 volt. Okay. And this diagram only I ask you to take the snapshot. Here they have given, but normally they won't ask all the pin detail, but here they have given. If it's not easy for you to remember, but at least remember for this supply pin, then similarly for X1 X2 oscillator pin and 37 clock out pin, that is only sufficient for you to remember. Okay, that is one question I have shown you. And one more thing. PSW, program status word. Program status word na accumulator 8 bit, state flag status flag 8 bit. So totally 16 bit will comes into the picture. Okay. And one more thing, timing diagram I showed you na. So maximum you see my higher order bus will be specified only for 3 bus, 3 clock signals only. So for all opcode machine cycle only 4 T states. The remaining memory read, memory write or will be 3 machine cycle only. Okay. Now I will go with the next assignment. I think you people are being tired after training from the college. But if you first you learn this 4 assignments. Okay, first you learn any doubt on this 4 assignment, you uh, come and ask me. Then after couple of days after that, I will put it for the so assignment to get over. Okay, students, kindly take the snapshot of this I am showing to you. Okay. This is T states for each and every instruction. Kindly take down. Screen not visible. Now you can see. Am I correct? Kindly take down the kindly take down the screenshot of this instructions alone. Okay. Then while we are solving for the problem, we will move on to that. Okay. Now I will stop share it and I will go for the assignment. I will go for the third assignment. I'll go for the third assignment. Okay. Now we go for the third assignment, ma. Which of the flag is not affected by CMP? What is the meaning of CMP? Na compare. You note down. You need not to study all the instruction, which is good. Compare na which in the we have seen 5 types of instruction sets are there. five types of instruction set. What na? Data transfer instruction, arithmetic instruction, then branch instruction, then when you go with the logical instruction and machine control instruction. I'll repeat once again: data transfer, arithmetic, machine control, branch, logical. Here in the five instruction, among this, data transfer will not change any flags. Okay, using data transfer instruction, flag will not be affected. That is one of the important point. Okay, make note of it. Data transfer instruction, none of the flag will be affected. Okay, so here, which of the flag is not affected by CMP? CMP na compare. If I want to compare with that, normally comparing with accumulator with register or accumulator with thing. So while I am comparing, if both are equal, na zero flag will set. If accumulator content is greater, na carry flag will set. But which flag will not set? Na parity flag. Priority is depends on number of ones only. So while I am comparing, whether I will check whether it is a greater number or equal number or lesser number. So while I am checking, these three flags only comes into the picture, not the parity flag. Okay. The next question: what is the size of the instruction of MVI, CFF? Okay, MVI, MVI now move immediately, CFF. Okay, now only I have seen 1 byte, 2 byte, 3 byte instruction. 1 byte now opcode alone. 2 byte now opcode plus 8-bit data. 3 byte now opcode plus 16-bit memory address. So you see, this is my opcode and this is FF is my 8-bit data. So opcode plus 8-bit data now it will comes under what ma? 2 byte instruction. Okay. Yes. Then next one. What is the size of instruction of LDA 1234? Kindly put it in chat. What is the size of LDA 1234? LDA 1234. How many byte? 1 byte or 2 byte or 3 byte? 1 byte na opcode alone. 2 byte na opcode plus 8-bit data. 3 byte na opcode plus 16-bit data. So LDA 1234 is LDA is one opcode. LDA now load the accumulator. Okay, that is opcode. 1234. 1234 is nothing but what? In hexadecimal 1234 now how many bit will come? For 1234 you write it in binary and post. Yeah, it's a 3 byte instruction. Correct, Rohit. 1234 now you have to understand that how I can write my 1234 now. 1234 in hexa now I have to write it as a 001 0010 and 0011 and 000100. So I have written, see, I will post it in that chat. 1, 2, 3, 4. Yes, clear? 1, 2, 3, 4. This is my binary value. So you have to understand LDA 1, 2, 3, or 4. Now LDA will be load the accumulator will be is nothing but my opcode. 1, 2, 3, 4 is my hexadecimal. Okay. How many T states? MVA, 7 T states. Why actually T state is one of the very big topic. That's why I asked you to take the snapshot. So that are very important. That alone you learn it. MVA, 7 T states. Okay. This program I will explain you how to calculate at last this fifth one and I think one more, fifth one and eighth one. How to calculate the time delay. Okay. What is the addressing mode of the instruction CMA? CMA, we have studied 5 addressing mode: direct addressing mode, indirect addressing mode, immediate addressing mode, register addressing mode. So CMA, implied addressing mode. CMA na complement the accumulate control. Why complement the accumulator is implied addressing mode na? No opcode is there. It is comes under 1 byte instruction and opcode itself specify. No operand is there. Opcode itself specify how to deal with it. Okay. What is the value of BCD value? We all know 1000. 100, what is the value? 8. 0101, 5. So 85 is the answer. Fifth and eighth I will tell you. Ninth one, one of the very important one. Kindly note down what is call and what is written. Call na kindly note down. call instruction, call instruction, program, program transfer from memory to memory, main program transfer to main program transfer to what is that? Delay program. Call na, call instruction la main program will transfer to delay program. Delay program. Okay, just now note down. And return instruction, return, RET na return, RET na return instruction, delay program to main program. Okay, delay program to main program. Delay program to main program. Okay, just note down this. Call instruction main program transfer to delay program, return instruction delay program transfer to main program. Okay, now you see D in 8085 first return instruction may appear before call. Okay, you all understand we can have multiple call and multiple return, but you always understand first my main program should to go to delay, so first call should be there, then only my return should comes. Okay, first return should not come. Call will transfer the program to main to delay, and return will transfer from delay to main. Which of the following statement regarding 8085 is false? Okay, 8085 la maskable irkalam, non maskable, vectored, non vectored irkalam. Okay, and it always synchronize with the IO device, and which is false na, you all understand. An interrupt service is only after the microprocessor completes the execution. I told in when you are in the mall, if there is a sudden fire accident comes, then my interrupt program will communicate to the microprocessor and it will stop the entire execution. It shut down the system or it will give alert to someone else. So always remember, maskable na I can enable the interrupt and disable the interrupt. Non-maskable na I cannot able to disable. Okay. And one more thing is okay, I forgot to say. Vectored na address of the interrupts will be there. Non-vectored na address will not be mentioned. Okay, and so vectored na for each program we have an address. That is also I will show the address. Note down the address also. Okay. Which of the following statement is true? Push na push from register to stack pointer. Pop na popcorn. Remember that. Retrieve from the stack pointer to register. Push always push the instruction to the stack. Pop means retrieve from the stack. Okay. So here always stack pointer will decrement by 1 when push instruction is executed. Pop na incremented by 1 when pop instruction is executed. Okay. Before entering into this, I will show you the one important thing. Kindly take down the, please take down this snapshot of this particular program. 8085 non-vectored, non-vectored. Okay. So each restart, RST stands for restart instruction. This will go to the particular address. They are asking in a program RST 0 na 000 plus 8 you have to you need not to study 00 plus 8 8 8 plus 8 16 16 na in hexadecimal 1 10 plus 8 18 18 plus 6 6 na 20 20 plus 8 28 so you have to perform hexadecimal addition. Okay, have you take down this non-vectored? Then one more I will tell you. Masked and vector interrupts. You please kindly take down. We have only 5 instructions. All are maskable. RST 5.5, 6.5, 7.5. Okay, all. And take down this vectored interrupt address that are non-vectored. Okay, that RST0 to RST7, that all software interrupts. But these are all hardware interrupts. RST 5.5, 6.5, 7.5. Take this, take this snapshot of this one. Okay. And Simna, I think, Simna set interrupt mask. Set interrupt mask. Please kindly take down this also. We have one question depending on that sim. Okay. So take down this RST 7.5 is positive edge sensitive. Positive edge sensitive. RST 7.5 is positive edge sensitive. RSST 6.5 and 5.5 are level sensitive, and put it going over the chat. That whatever point I am telling, that's very important. RIM, take down this also, read interrupt mask. Okay, I think this is all enough. Read interrupt, this allow. Okay, now I will go for the assignments. Okay. Which of the following is non-vectored interrupt? So you see, trap RST 5.5, 7.5. INTR, I don't have address. So that is a non-vectored interrupt. Okay, 12th question. Which of the following instruction can control maskable interrupts? Okay, EI na, write down enable the interrupt. EI na, enable the interrupt. DI na, disable the interrupt. Okay, EI, DI na, enable. So I can mask na, enable, and I can disable. So both A and B. That 13th question. 14th question. Which of the following interrupt is not present in 8085? 8085, we have only these 5 interrupts. Okay. And the correct answer is RST 3.5. To confuse you, they given RST 3.5. Okay. We have only these 5 interrupts. Always remember RST 8085 has only 5 interrupts. Okay. 8085 is having 5 interrupts only. Which of the following interrupt is non-maskable? One of the very important question. Trap is I cannot able to mask the trap. Highest priority interrupt. Which of the following is a trap? Or else I can say highest priority interrupt. Highest priority interrupt. Okay, I think the time is already getting late. So I will finish it over this. Okay. The delay calculation alone, I will put it in the group. Okay. If you have any doubt, you ask me. Week 3, get over. Week 4, I think week 4 are very simple. It's week 5. Okay, sorry. Actually, week 4, which is given here, will be students, are you there? Around it is going 1 hour 33 minutes. Okay. So I will show you week 4. I think week 4 we are having around whatever we have seen that only. Which of the following I have shown you now? Call 0020. So RST 0 na, 000, RST1, RST2, RST3, RST4. Every time you add 8 hexadecimal, so call 0020 is RST4 address. Which of the following machine operation is not present in the restart sequence? Okay, so microprocessor sends INTR signal. You all understand, microprocessor never sends INTR signal. Microprocessor receive only request, will not send by the processor, always remember. So microprocessor sends INTR signal is the wrong one. Microprocessor receives INTR signal, that is the correct one. Which of the following is the longest instruction? Na call, because call is having around the maximum, once again, the call is having around 18 t states. Call is having 18 t states. Okay, which of the following statement is false? Interrupt process is asynchronous, and interrupt INTR must remain active enough to allow the longest instruction. INTR must active for 17.5 T states. INTR must remain active for 12 T states. Actually, that is only the false statement. The remaining and all, we can say that it's all true only. See, listen, they are matching a column. I have put it in the chat also. So RST 5.5, it's a level triggered. RST 6, it's a software interrupt. RST 7.5, it's a edge triggered. And RST 4.5, it's edge and level triggered. Okay, so you have to remember that 5.5 is level triggered and 7.5 is nothing but edge triggered. 4.5 is edge and level triggered. Okay, similarly here you can see that we can match it. Okay, INTR we are mentioning as a non-vector. RST 5.5 is, we all know that it's a maskable interrupt. Trap is non-maskable. RST 0 to RST 71's software interrupt. Okay, INTR we don't have any address to do that, so it's a non-vectored interrupt. And RST 5.5 is maskable interrupt, and trap is non-maskable, and RST1 is software interrupt. Which of the highest priority than RST 7.0? Not one, RST 7.5. Comparing to all other interrupt, trap is the highest priority. Okay. What is the following instruction do in an 8085? EI na enable the interrupt. Okay. You have to go to the RIM instruction. Okay. This I will write the program and I will put it in this 8th one. Okay, 8th, and there I have showed given you now that I will put it, write it and put it in a group. Which of the following statement is false with respect to trap? Trap lowest priority, that is the trap. Trap is both non-maskable, both edge and level triggered. Trap needs to low and stay at to be low to be recognized. When it receives, it will become higher. So lowest priority is false. Okay. Which of the following instruction cannot be used to mask the RST 6.5 interrupt? Okay, RIM, EI na I can enable the interrupt. DI na I can disable the interrupt. SIM na set interrupt mask. Okay, so you just, I think some of the second year students been that. EI na enable the interrupt. Enable the interrupt. Okay. DI na disable the interrupt. Okay, disable the interrupt. And SIM na set interrupt mask. Set interrupt mask. RIM na read interrupt mask. Okay, I can read only, I cannot do any operation. Read interrupt mask. So set interrupt means I can mask and non-mask. Read na I can know the status of the interrupt only. So here I cannot use to mask using which instruction na RIM. Voltage level RS232, it all been used as a bus, USB bus, CAN bus. So similarly RS232 na my voltage level is plus 15 to minus 15. Which of the following instruction is used to check the status? That is RIM. RIM, I can check the status. I want to mask or dim. I want to mask or I have should not. I have to non-mask the interrupt. Now I will use the sim instruction. Okay. Which of the following pin is used for DMA transfer? HLDA. HLDA na hold acknowledgement. HOLDL na hold. SID na serial input, serial output. Ready na, what is the purpose of ready na? My microprocessor will be in a super fast. My peripheral will be slow. So while I want to communicate, my processor want to communicate with the peripheral devices, using ready signal only it will communicate. Okay. So hold and HLDA is for DMA transfer. So for DMA transfer, we always use hold and HLA. DMA transfer. So I think whatever I am put it in chart also, you make note of it. I think it's DMA signal na. You have to understand DMA, direct memory access. Okay, so direct memory access, my processor will not comes into the picture. So that what I will do, I will use two pins. Hold na request. I will ask the processor as a request. Once microprocessor gives acknowledgement, it's nothing but a HLDA. The A always stands for acknowledgement. Hold na request. This is A for acknowledgement. Okay, and 14th question. Very simple. What is the duration? I will use 1 by 46.6k. 1 divided by 46.6k. 6 into 10 power 3 into I think 1000. I think it gives around some 21.46 microsecond. 21.46 microsecond. Okay, reverse of this. And what is the other one? What is the vector address? RST 7.5. That is also I have shown you. So RST 7.5, RST 6.5, RST 5.5. Remember the vector address. And RST 0 to RST 7, remember the non-vectored address. Okay. So that is 003C. Okay. So I think that delay program calculation, and then here one program is there, that calculation whoever not I have covered, that I will write it and post it in the group. You have any other doubt, you will ask. Now I am going to end the stream, and in the same link, I think 1 hour 42 minutes is there. You just want to see any important content, you may use it for further purpose. Okay, so thank you all students for your patient listen. Thank you. I'm going to end the stream. Thank you all.